Alright, ladies and gentlemen, we're going to take a look at parabolas. I know you're saying that we've already looked at parabolas, but we haven't learned everything that we need to about parabolas yet. So we're going to take a look at this parabola and see what we don't know so far. So y equals x squared plus 4x plus 3. We know that if we graph that, it's making some kind of parabola somewhere. Maybe it even crosses the axis, and we have some zeros there. What we are going to learn, though, is a different form of this. We're going to learn what's called the standard form, or the vertex form sometimes as well. So this is what it is here. You guys are used to the y equals ax squared plus bx plus c form, which is good for like the quadratic formula. This one is better for graphing though, because at this value hk is the vertex. We'll take a look at that in a minute. So if I look at, what was the equation there? Y equals x squared plus 4x plus 3. Plus 4x plus 3. We're going to work on that and try to get it into this form, and kind of you'll see why we do that and what it does. So the idea is to get something squared. So we're going to use the completing the square that we learned before. So before we complete the square, it said to get all the x's to one side. That's what Gandalf told us before in the video. So if we want to get all the x's to one side, we need to subtract 3 on both sides. Then Gandalf told us that we need to find our magic number by taking this number, dividing it by 2, and squaring it. We can add that to both sides. So I'll do that. Y minus 3, I'm going to add something there so I'll leave some room, is equal to x squared plus 4x, and if I divide that number by 2 and square it, I get 4. So that's my magic number. That number is going to give me my perfect square. So if I factor this now, add 4 on that side too, right? If I factor this now, I get x plus 2 times x plus 2, which is x plus 2 squared. And if I subtract 1 from both sides, I get y equals x plus 2 squared minus 1. And now I am in my vertex form here. Alright, so we do that because we can see clearly where the vertex is. It's at hk. Notice that this is negative h here in the formula, so our h value is going to be the opposite sign of whatever that is. So my vertex here in this problem, vertex will equal to negative 2, negative 1. Alright, we're going to graph that on a calculator and see what it looks like. So we're going to use a different part of the calculator that you guys are used to. We'll go to the graph like usual, and then when we graph it, I'm going to hit menu, graph, and go to equation. So we have all these things. We have a line, a parabola, circle, ellipse, hyperbola. We're going to use those, all those other ones in this unit, but we're going to look at first parabola. Let me go back and do that again so you can see better. Alright, equation. If we go to parabola, it gives us some different options. So the first option is the one we just looked at. The second one is the standard form that we looked at before, and then these two have x equals, and we'll look at x equals 1 later. So we're going to put the standard form in here, and all we have to do is fill in these numbers, and it'll graph it for us. So our a value here, there's just a 1 in front of there. So I'll put a 1 in there. And our next one we have minus, it says. So we have to put in a negative 2 because we know it's x plus 2 and there's already a minus there. Alright. And then the last one is -1. Alright. If we hit enter, we have a graph. And it should have a vertex at -2, -1, like we said. So -2, -1. We can actually use this now to analyze some different things. So if I hit analyze graph, and then down at the bottom it says analyze conics, there's some cool stuff here. We can see what the vertex is, vertices. If you just click on the graph, it tells us that it is at 2, 1. -2, -1, which we already knew. It can also tell us some other things that we'll use are what's called a focus. So focus, if we click this graph, it tells us is at this point -2 3/4. And we'll get to what that means. So that'd be right in here somewhere, -2 3/4. So I don't know where that cursor is there. The last thing that we're going to look at is what's called the directrix. So if we do analyze conics, the directrix, and then we click our formula, it says the directrix is that y equals -5/4. And I'll let you guys know in a second what that directrix is. So this is completing the square to change it to vertex form. And we're going to look at a couple different things now of parabolas that you haven't looked at before. So focus and directrix. So basically, if I have a parabola, let's draw a parabola here, something like this. There's this point called a focus that sits inside my parabola. All right. And there's another point. It's going to be, oh, messed it up. Let's try again. All right. So we have a parabola. And there is a point inside of my parabola. And there's this other thing called a directrix, which we usually draw with a dashed line. It's a dashed line. It's always going to be a horizontal line there if my parabola is going up and down like that. And there's something special about these two things, the focus and the directrix. Basically, I can take any point on this parabola. So if I pick a point, any point, say that point, this point is the same distance from the focus to the directrix. That's equal to that. Any point on here. If I take a point way up here, this should be equal to this. Now my parabola isn't perfect, so it's not going to look quite exact. And then of course also if we just draw a line going straight down, this point would be the same distance to the focus as this point is to my directrix. So when we looked at the calculator, it gave us, this was our vertex, -2, 1. The focus is at -2, -3/4, so a little bit above there, somewhere in there. And the directrix is going at y equals -5/4. So it's right down there a little bit. Uh-oh. Better hurry up and get through this lesson. Alright, so last problem to look at is this. So in this problem, we are going to try to get it into this vertex form. It's going to be a little trickier. The reason is because of this 2 here. Alright, it's going to give us an extra step. So start things off, we are going to do the same thing we've always done, which is get the x's by themselves. Alright, so to get the x's by themselves, we need to subtract 53 on both sides. So we have y minus 53 is equal to 2x squared plus 20x. Sorry, my writing's a little shaky there, it looks like. So the next step is going to be to get this x squared by itself. So to get the x squared by itself, we are going to factor out this 2. We've done that before. 2 x squared plus, not 10, yep, 10x. So if I multiply this together, 2 times x squared, I get 2x squared, and 2 times 10x, we get 20x. Alright, so reason we're doing that, I promise. So now the next step is to add our magic number, right? The magic number is this number divided by 2 and squared. So we get y minus 53 is equal to 2 times x squared plus 10x plus, if I divide that number by 2 and square it, I get 25. Alright, so this is the tricky part. I'm going to put a little asterisk here. We have to remember now, we added 25 on the right side, so we need to add 25 on the left side too. I'm going to make a little room here. Too much room. Alright, so y minus 53. And we need to add 25, except we didn't really add 25 on the right side. We added 25, but it's inside these parentheses, which is multiplied by 2. So we actually added 50 on the right side, because 25 is inside these parentheses that get multiplied by 2. So I need to add 50 on this side too. So that makes sense. So if I combine my negative 53 and 50, I get y minus 3 is equal to 2 times, I'm going to factor this, x plus 5 times x plus 5. Now I can simplify a little bit more. I can add 3 to both sides. And when I do that, I'm also going to change this x plus 5 times x plus 5 to x plus 5 squared. And we get plus 3 at the end. So our vertex is going to be at negative 5, positive 3. You can graph in your calculator to check it out. This 2 here is going to affect how flat or arched my parabola is going to be. All right, one last thing I want you guys to do, part of your homework, is to plug this in your calculator. Notice that this is an x. All right, so there was an option on the calculator to do that same one when we plugged in this parabola from earlier. There was an option that said x equals. So choose that option, plug this in, and see how this graph is different than the other one. And you can report back to me in class. I will see you there.